Well, in this video I want to prove the standard equation for a hyperbola. And in previous videos I did the ellipse, parabola, and circle, the other three conic sections. And we see that they're all defined differently because they're different graphs, but they're all related by the idea of these focal lengths, by the idea with the directrix on parabola as being a set of points equal distance, or the sum of distances or differences of distances being equal. That's the same with the hyperbola. So let's go ahead and set this up. Let's say that the center of our hyperbola is at the origin, and that it has two vertices, and they're going to be these points directly above and below the center. We'll say they're a distance away, so that's the point 0a and the point 0, negative a. Well, with these hyperbolas, they're going to have two foci, and it's kind of similar to a parabola in that this focus will set inside the opening hyperbola, and we'll say that it's c distance away, so we get the point 0c and 0, negative c. So if this is the case, I ask, if I have a point xy, how are we defining this hyperbola? Well, the hyperbola is the set of all points for which the difference in the distance to each of the foci is some constant. So if I draw a line from this point xy down to one foci, and I'll call that distance d1, and I draw a line to the other foci and call that distance d2. The definition of the hyperbola is that the absolute value of d1 minus d2 will equal some constant value, and I'll call my constant value k. So then I ask, well, what will that constant value be? Well, let's say we test it with this point 0a. If I draw a line straight to one focus, it will be to there. Well, that distance is going to be a plus c. Well, if I draw a line to this other focus, that distance is going to be c minus a. So the difference in these distances will be a plus c minus c minus a. When we distribute our negative through, that will simplify to 2a. So our hyperbola is defined as a set of all points for which the difference in these distances is equal to 2a. So now I ask, well, what is our standard equation for this? So let's calculate what these distances are going to be. If you remember our distance formula, distance is the change in x plus the change in y, each of them squared, and the square root of the entire thing. So if we apply that here, what is our d1 going to be? Our d1, the distance, is the square root of x minus 0 squared plus y minus negative c squared. Then we subtract the distance of d2. Well, what's d2 going to be? X minus 0 squared again plus y minus c squared. And the difference of those two distances for any value of x and y will equal 2a. So now let's see if we can just simplify that. So if we go ahead and bring one of our radicals over to the other side, I'll add that. On the left side, I'm left with the square root of x squared, just simplifying since x minus 0 is simply x, plus y plus c squared. That will equal 2a plus the square root of x squared plus y minus c squared. So then if we square both sides of this equation, the left side we clear our radical. That'll simply be x squared plus y plus c squared. And on the right side we FOIL it out. We'll get 4a squared plus 4a times the square root of x squared plus y minus c squared. And then we'll have the radical squared, so that just clears the radical, and we have x squared plus y minus c squared. And now from there we can just expand out some terms and we can start canceling things. So on the left side I'll get x squared, multiplying out y plus c squared, I'll get y squared plus 2yc plus c squared. And on the right side, my 4a squared still there, 4a times the radical, still there. Then I'll have plus x squared, and multiplying y minus c squared out, it's y squared minus 2yc plus c squared. So now we have a pretty lengthy expression, but we can start canceling some terms. We'll have x squareds, and that should have been squared there, cancel. Y squareds will cancel. C squareds will cancel. So now to simplify this, let's take this negative 2yc and add it, so that on the left side we'll have 4yc. On the right side we have these two terms left, 4a squared plus 4a times the square root of x squared plus y minus c squared. So now what can we do to further simplify this? Well, first let's bring this 4a squared over, and let's go ahead and divide 4 out from both sides of the equation. So that will leave us with yc minus a squared equal to a times the square root of x squared plus y minus c squared. And that's simply combining two steps. I divided by 4 and then brought the 4a squared over. So now let's square both sides of the equation. By squaring, we'll full out the left side. We'll get y squared c squared minus 2yc a squared plus a to the fourth, and that will equal a squared times what's under the radical, x squared plus y minus c squared. Now from here let's go ahead and multiply out our y minus c squared, and we'll try to simplify. We'll get y squared c squared minus 2yc a squared plus a to the fourth equal to a squared times x squared, plus we'll have a squared times y squared minus a squared times 2yc plus a squared times c squared. Now we're getting another pretty lengthy expression, but at this point let's make the substitution that c squared is equal to a squared plus b squared, which is how we define c. So by doing that, I'll get y squared times a squared plus b squared minus 2yc a squared plus a to the fourth equal to a squared x squared plus a squared y squared minus a squared 2yc plus a squared times a squared plus b squared. And again, that gets kind of sloppy, but you may notice that we can cancel a 2yc a squared. And then if we go ahead and distribute through the parentheses, we'll get y squared a squared plus y squared b squared plus a to the fourth equal to a squared x squared plus a squared y squared plus a to the fourth plus a squared b squared. And now let's see what else we can cancel. We have a to the fourths on both sides that will cancel, and we have an a squared y squared on both sides that will cancel. So then we have y squared b squared equal to a squared x squared plus a squared b squared. We're almost home from here. Let's bring this a squared x squared over. Y squared b squared minus a squared x squared will equal a squared b squared. And now we simply divide by a squared b squared on both sides, and we'll have our standard form of y squared over a squared minus x squared over b squared equal to 1, which is our standard form of a hyperbola centered at the origin. So if we relate that back to our graph above, our standard equation we found was y squared over a squared minus x squared over b squared equal to 1. Whenever you have your y term being the positive one, it opens up and down vertically. If your x squared is positive and you're subtracting y squared, it will open horizontally. These a and b distances form somewhat of a rectangle inside of here, and that dictates how your asymptotes fall, where your vertices are lying, and you use a and b to calculate your c. So with the basic information of knowing what your a and b values are, you can get a pretty good sketch of what the graph will look like. But this all comes back to the idea that the hyperbola is a set of points for which the difference in the distances is some constant value. And from that we derive our standard equation, y squared over a squared minus x squared over b squared equals 1.